So as I mentioned in the previous video, if you didn't watch it, in this video we're going to be looking at a rework of a piece of code that I helped write back in 2013 for our robot BP. Belts and Pulleys was the source of that name. BP was a frisbee shooting robot that could fling frisbees, 30, 40 miles an hour, maybe more. This is a very basic rework of that code. Not all of the code is represented here, and in fact, this is not the original code. We will see a piece of code later that will give more of a comprehensive look at what the code actually was for BP, with a little bit of reworking for the more modern FRC programming paradigm. But that being said, let's have a quick discussion about this. This video should be relatively fast compared to the last one. We have 7 speed controllers, 7 motor controllers for this robot BP. We have one for front left, front right, and rear right motors for the drivetrain. We have front shooter and rear shooter. There were 2 motors in the shooter of BP, one in the front, one in the back. They work together to fling the frisbees out of the robot. And then we had a window motor, which was called the frisbee kicker. It was literally just a window motor with a piece of steel stuck in it, and it would spin around and kick frisbees into the spinning wheels of the shooter and fling them out of the front of the robot. Fairly straightforward. We have 3 speed controller groups, one for the left drivetrain, one for the right drivetrain, and one for the shooter. We have differential drivetrain. This is just a composite unit so that we control the left side and the right side of our drivetrain together as one unit. And then, of course, we also have our Xbox controller object called driver, which just allows us to actually control our robot. In our robot init method, we set up all of our motor controllers using PWMs 0 through 6, everything in order as I described them before. We also create our speed controller groups, one for the left side of the drivetrain, one for the right, and one for the shooter. And then, of course, we create our drivetrain using the left side of the drivetrain and the right side of the drivetrain. And we create our Xbox controller given USB 0 on the driver station. Now, I didn't write an autonomous for BP. BP did have an autonomous originally. You will see if you watch the more advanced videos after this one how that all works. But we'll talk about that in a minute. But we do have some stuff in teleop periodic that I want to talk about. So, in this instance, BP was arcade drive. We have a regular arcade drive where we get the Y-axis on the left joystick to make the... that's wrong. Never mind. There we go. Let's fix that. This is supposed to be arcade drive, not tank drive. There we go. That's better. We get the Y-axis on the left stick of the Xbox controller for moving forward and back. And we get the X-axis on the left stick of the joystick to move left and right. Now, the shooter is set based on the value of the trigger axis on the right-hand side. So if you're familiar with an Xbox controller, there is a trigger on the right-hand side that is an analog trigger, so it has a range to it. You can get that right-hand analog trigger by calling Xbox controller object, in this case driver, get trigger axis, and then the hand side that you want to use. So you could say hand.k left if you wanted the left hand, or hand.k right, which is what we're doing now. The only other thing that we have is the if statement for the kicker, the frisbee kicker. What we do is we say if driver.getAButton, so if the A button is pressed, then we will move the kicker forward so that it kicks a frisbee into the shooter. It may not have spun this way. In fact, I don't think it did. I think it spun this way. Yes, it spun this way in order to kick a frisbee into the shooter. Bear with me. This is like the 7th video that I've done tonight. I'm getting tired. If that is not true, then we check the B button. So if the B button is true, then we'll spin the frisbee kicker in the opposite way. I did this because sometimes frisbees would get stuck in the hopper that we had for frisbees. So we added something to make it so that the frisbee kicker could spin backwards. That way we could try to dislodge by moving the frisbee kicker back and forth like this. Otherwise, if neither of those buttons are pressed, then we set the value of the frisbee kicker to 0. Fairly straightforward, nothing complicated. This is very basic code that would technically make BP work. That being said, I do have plans in the future to build BP's shooter and have it available for demos. It's not built right now, so this video will not be accompanied by a demonstration, sadly. However, that being said, this is technically the last video in the beginner stages. There are 2 other videos that are coming at least that will be more advanced in nature, that will talk about something called command-based programming, which is a different way of programming an FRC robot that sort of modularizes or breaks the robot code into parts to sort of segregate when things happen. These videos are probably going to be much longer in nature, and so I can get all of the things that I want to talk about across. But generally speaking, you don't necessarily have to watch them. If we do end up using command-based next year for some reason, it may be beneficial to watch them, but for now, I wouldn't worry about it too much. That being said, if you have any questions about this video, what have I been saying? Facebook, email, text, call, get a hold of me through a friend. As I've mentioned, my gallbladder surgery is coming up on the 21st of December, so I've been trying to get everything done before then. But of course, if you have any questions and the 21st of December has come and gone, you can send me a message and I'll get back to you when I can. I hope to be recovered by kickoff, but we will see. My surgery is exactly 2 weeks before kickoff, so I'm hoping that everything will be smoothed out and I'll be good to go by then. But that being said, if you want to continue the next stage, feel free. Otherwise, you're done.